Part 1. The Boy Who Changed the Universe. Imagine a world where no one truly understood why an apple falls to the ground, why the moon never crashes into Earth, or how the planets continue their endless journey around the sun. For thousands of years, these mysteries puzzled humanity. Then, in the 17th century, one quiet, curious young man would uncover answers that would forever transform science. His name was Isaac Newton, a man whose discoveries laid the foundation of modern physics and changed the way we understand the universe. Isaac Newton was born on January 4, 1643, in the small village of Woolsthorpe, Lincolnshire, England. His arrival into the world was anything but ordinary. He was born prematurely and was so tiny and fragile that many believed he would not survive even a single day. His mother later recalled that he was small enough to fit inside a quart-sized mug. Before Newton was even born, tragedy struck. His father, also named Isaac Newton, passed away just 3 months before his birth. At only 3 years old, Newton experienced another heartbreaking loss when his mother remarried and moved away, leaving him in the care of his grandmother. This lonely childhood had a profound impact on him. Newton became a quiet and deeply thoughtful child who often preferred books and experiments over playing with other children. While many boys his age enjoyed outdoor games, Newton spent hours building miniature windmills, water clocks, sundials, and mechanical toys. Even at a young age, his extraordinary curiosity was impossible to ignore. Initially, Newton was not considered an exceptional student. In fact, he often ranked near the bottom of his class. Everything changed after a rivalry with another student motivated him to work harder. Determined to prove himself, Newton quickly rose to become one of the best students in school. His family hoped he would become a farmer and manage the family estate. But farming was clearly not his calling. Instead of watching crops or livestock, Newton was often found reading books beneath trees or sketching scientific ideas in notebooks. Realizing his remarkable talent, his relatives eventually allowed him to continue his education. In 1661, Newton entered Trinity College at the University of Cambridge. At the time, universities still taught many ancient ideas based on Aristotle. But Newton was fascinated by the revolutionary work of scientists such as Galileo Galilei, Johannes Kepler, and René Descartes. He spent countless nights studying mathematics, astronomy, and philosophy far beyond the university curriculum. Then, an unexpected disaster changed history. In 1665, a devastating outbreak of the Great Plague swept across England. Cambridge University closed its doors, forcing Newton to return home to Woolsthorpe. For many students, this would have meant lost time. For Newton, it became the most productive period of his life. Working alone without professors or classrooms, Newton entered what historians now call his annus mirabilis, his year of wonders. During these 2 years of isolation, he developed the early ideas of calculus, explored the nature of light, and began formulating the principles that would later become the laws of motion. But one simple event would become the most famous scientific story in history. According to legend, Newton was sitting beneath an apple tree when he saw an apple fall to the ground. Contrary to popular belief, the apple did not strike him on the head. Instead, the falling apple sparked a profound question: why do objects always fall straight down? More importantly, Newton wondered whether the same invisible force pulling the apple toward Earth could also be holding the moon in its orbit. This seemingly simple question led to one of the greatest breakthroughs in human history. Newton realized that gravity was not a force limited to Earth. It was a universal force acting on every object in the cosmos. The same invisible pull that causes an apple to fall also governs the movement of planets, moons, and stars. Part 2. The Laws That Changed the World. By the time Isaac Newton returned to Cambridge University, he was no longer just a brilliant student. He was quietly becoming one of the greatest scientific minds the world had ever seen. The ideas he had developed during his years of isolation were unlike anything anyone had imagined. Yet Newton wasn't interested in fame. He rarely spoke about his discoveries, preferring to spend long hours alone, surrounded by books, papers, and experiments. One of his biggest obsessions was understanding motion. Why does a ball eventually stop rolling? Why do planets never fly away into space? Why does a cannonball follow a curved path instead of moving in a straight line? These questions had puzzled philosophers for centuries. After years of careful observation and mathematical calculations, Newton introduced what are now known as the three laws of motion, three simple principles that completely transform physics. The first law, often called the law of inertia, states that an object at rest will remain at rest, and an object in motion will continue moving in a straight line unless acted upon by an external force. In everyday life, we experience this when a moving car suddenly brakes and passengers are thrown forward. The passengers continue moving because their bodies want to maintain their motion. The second law revealed the relationship between force, mass, and acceleration. Simply put, the greater the force applied, the greater the acceleration. But heavier objects require more force to move. This relationship, expressed as F equals ma, became one of the most famous equations in science and remains essential in engineering, aviation, robotics, and space exploration. The third law may be the most recognizable. For every action, there is an equal and opposite reaction. When a rocket launches, its engines push hot gases downward. In response, the rocket is pushed upward with equal force. Without this principle, modern space travel would be impossible. Together, these three laws explain nearly every type of motion observed on Earth. From a child kicking a football to the launch of satellites into orbit, Newton's principles still govern the physical world today. But Newton's curiosity extended far beyond motion. Around the same time, he became fascinated by light. Most people believed that white light was pure and colorless. Newton suspected otherwise. He darkened his room and allowed a thin beam of sunlight to pass through a small hole onto a glass prism. As the light emerged, it spread into a brilliant spectrum of colors: red, orange, yellow, green, blue, indigo, and violet. This experiment proved that white light was actually made up of many different colors. Even more remarkably, Newton passed the rainbow through a second prism, recombining the colors back into white light. It was a groundbreaking discovery that forever changed the science of optics. To improve astronomical observations, Newton also designed the world's first practical reflecting telescope. Instead of using large glass lenses that often distorted images, his telescope used a curved mirror to gather light. The instrument was smaller, more powerful, and produced much clearer images of distant objects. His invention impressed scientists across England and led to his election as a member of the prestigious Royal Society, one of the world's leading scientific institutions. Then came the work that would define his legacy forever. In 1687, Newton published Philosophiae Naturalis Principia Mathematica, commonly known simply as the Principia. This extraordinary book united his discoveries on motion, gravity, and mathematics into a single framework. It demonstrated that the same laws governing an apple falling to Earth also governed the movement of the moon, planets, and comets. For the first time in history, the universe appeared to operate according to predictable mathematical laws, rather than mystery or superstition. Part 3. The legacy that shaped the modern world. By the late 1690s, Isaac Newton had already transformed mathematics, physics, and astronomy. Most scientists would have spent the rest of their lives enjoying the recognition. But Newton's journey was far from over. Surprisingly, the next chapter of his life had little to do with laboratories or telescopes. It involved fighting crime. In 1696, Newton was appointed Warden of the Royal Mint, the institution responsible for producing England's coins. At first, the position seemed ceremonial, but England was facing a serious financial crisis. Counterfeit coins flooded the economy, and criminals were melting down silver coins for profit. The country's currency was losing public trust. Newton approached the job with the same determination he'd shown in science. Instead of staying behind a desk, he personally investigated counterfeiters. He disguised informants, gathered evidence, questioned witnesses, and tracked down some of England's most dangerous criminals. Many counterfeiters were arrested and brought to justice because of Newton's relentless investigations. His success was so remarkable that he was promoted to Master of the Royal Mint in 1699, a position he held for the rest of his life. Under his leadership, England's currency became more secure and stable, strengthening the nation's economy. By now, Newton had become one of the most respected figures in Britain. In 1703, he was elected president of the Royal Society, the country's most prestigious scientific institution. He would remain president for more than 2 decades, guiding scientific research and influencing generations of scholars. Then came one of the greatest honors of his life. In 1705, Queen Anne knighted him, making him Sir Isaac Newton. Interestingly, he was one of the first scientists ever to receive a knighthood, not for military service or political achievements, but for his extraordinary contributions to knowledge. It was a powerful message that scientific discovery had become essential to the progress of civilization. Even in his later years, Newton never stopped working. He continued writing, experimenting, and studying subjects far beyond physics. Few people know that he devoted thousands of pages to alchemy, the ancient search for transforming metals into gold. He also spent countless hours studying theology, biblical chronology, and ancient history. In fact, he wrote more about religion than about science, though most of those writings remained unpublished during his lifetime. Even centuries later, his ideas continue to guide engineers, physicists, astronomers, and mathematicians across the globe. In the 20th century, Albert Einstein revolutionized physics with his theory of relativity. Yet Einstein himself acknowledged that his work extended Newton's rather than replacing it. For everyday life, and even for many space missions, Newton's equations remain astonishingly accurate. Today, Isaac Newton is remembered not simply as the man who discovered gravity, but as the scientist who revealed that the universe follows elegant, predictable laws. He showed humanity that nature could be understood through observation, logic, and mathematics rather than superstition or guesswork. His story also carries a timeless lesson. A premature child who wasn't expected to survive, a lonely boy who struggled to fit in, a student who nearly became a farmer, became one of the greatest minds in history. Newton's journey reminds us that curiosity can change the world, that setbacks can become opportunities, and that one question asked at the right moment can reshape human civilization forever. The next time you see an apple fall from a tree, remember that what looked like an ordinary moment inspired an extraordinary question. And from that single question came discoveries that changed science, transformed technology, and helped humanity understand the universe itself. Isaac Newton didn't just explain how the world works, he changed the way